Oh, okay, let's start the presentation. Okay.
Okay. Well, my research is fundamented in the integral geometry and use the algebraic geometry to obtain the solutions of different field equations and consider the moduli problems given by the different spaces, moduli spaces in different levels of this study of the field theory, and obtain these space classes, which the solutions, which are the solutions of these field equations. In here, this table, we have this in the first column, the different moduli spaces obtained in this theory. And the first lines, the three first lines are the classic moduli spaces studied in the twistor theory and other theories. And to start of this fourth line, and after are the moduli spaces obtained for me or by me. And this second column show the different D models used in this theory to obtain the solutions throughout of the cohomology of cycles and give the solutions of these different field equations. The last case is the most difficult case because require the Hitchin mappings and other tools in algebraic geometry and derived categories. In all this investigation or research is considered the space-time modeled by a complex Riemannian manifold, including singularities. Precisely, this is the goal of this theory that I am constructed in this research, and consider as fundamental theorem the Kashiwara theorem to construct the equivalences between the different derived categories of the objects to construct the moduli spaces which will give the equivalences throughout of the integrals, certain integral transforms as Penrose transform and different versions of this integral transform, and other related with this transform as Radon transform or Radon transform of dimensions, and obtain a micro local analysis to generate a generalization of the Penrose transform in the derived categories. The results, the immediate results can be obtained is obtaining of moduli space of the equivalence manifolds of the Calabi-U manifold and Lagrangian submanifolds, and the terms of the field equations are differential operators corresponding to the holomorphic G bundles. And in this step, we have the two objects, the geometrical objects and the algebraic objects, and we establish the equivalence between these objects. throughout of the Penrose transform of the version, of the special version of the Penrose transform. And we need characterized cycles to determine under this transform, and we start with this double fibration, where this double fibration is very important because will obtain the cycle, the Lagrangian cycles in this manifold of the Lagrangian submanifolds, and with these tools obtain these solutions to different field equations, and obtain a geometry implicit in the topology of these differential operators that whose kernel is complies the isomorphic of the version of the generalized version of the Penrose transform in the solution of in the integral solution or integrals of the differential equations. And our result, the important result is this. The model space obtained by the way is the model space, the flat space, where the characteristic cycles are the Lagrangian submanifolds given in lambda, defined with a complex Z of certain special shape of the holomorphic G bundles, called in the Eigenschiff of Hick, where Hick is the derivative category in the deformation theory, and Hick category has all solutions that we want throughout of this route. And then the Hick Eigenschiff will be confirmed by the Lagrangian, this category, whose shift must be the Lagrangian sub y. This is a Calabi-U manifold. Remember that lambda is a Lagrangian manifold of the Lagrangian submanifolds that must be corresponded to the M folds of the Calabi-U manifold. It's more important consider the following theorem or this dimension, because this equivalence in between two categories is given in the coherent models, the models between two different ships, and include the holomorphic bundles corresponding to the Lagrangian submanifolds. And in this step, we need use a representation of the space-time as a model space, and is very useful. The representation given by the Hitchen, and we have this in this relation, and obtain the complex by this sequence, the infinite sequence for different dimensions. And remember, we need use the model space as a base space to obtain the other generalization in the other level. Then we can give the following lemma on equivalence between object of model space. This is the model space as a goal in this theorem. And the singularities holes of the space-time with corresponding characterization given by this representation of the Hitchin model, Hitchin moduli space, and the lemma is given by this sentence. The characteristic cycles in in this space as Lagrangian have their equivalent in the flat space, given by the super twistor space as lines bundles in P. This is imagine of this the projective space in certain dimension. The cycles are solutions of the field equation in L-holomorphic bundles to the space-time M, which includes singularities. And the demonstration consider this isomorphism, which is given in other theorem published in these documents, and consider this manifold given by the cycles, that is to say, the Lagrangian cycles, that is to say, the Lagrangian manifolds, and use these integrals to obtain these corresponding forms used by the obtain the integrals or solutions using the Penrose transform, or the version, the generalist version of the Penrose transform, to obtain the solutions in this case, and obtain the equivalence between the L-holomorphic bundles with the algebraic modules in which is the D branes as orbifolds, like in the models on the line bundles in the super projective space. And use the corresponding algebraic tools of the functors. These functors are constructed as a Zuckerman functors, and complex this equivalence, and various of much work of these relations you can find in the Pierre Shapira and Andrea Diagnolo works, and these details can be found in these works. An example, we consider the model space given by the Kellerian model space. That is to say, are the space-time modulo hypersuperfices, complex hypersuperfices, included the singularities. We want to establish the equivalence between the spaces and spaces, where these spaces are super projective, super twistor projective space. Here we can construct a model space of the space-time carpet using the Kellerian model space of the branes as the models, and stacking with these strings, this carpet, consider the large exact sequence. These details you can find in these documents. And we can stacking the carpet of the space-time throughout the moduli spaces or the relations, the equivalence relations given in different levels. The classical level, the after level given by the exact sequence of different superprojective spaces, and this level in super twistor projective spaces. And where this is the classical moduli space given by this superprojective space. All this research is given by microscopic aspects in the space-time. Remember, and these aspects are most important because they all happen in the universe is a consequence of this happen in the microscopic level. The category of the Lagrangian manifolds is given by this space. This space is analog with this space for this study, this particular study. Well, and with this study, I want to obtain a theory of the universe through the integral operators because I think this the good way to obtain this complete theory, because the integrals or integral transforms are powerful tool to obtain or relate microscopic and macroscopic aspects of the universe. Thank you.